All right, so we want to solve this rational equation. It has one variable, so we know we're solving for the x variable in this case. And we always want to start, whenever we're working with a rational function or rational equation, is be sure that we identify the restrictions on the domain. Before I do that, I want to be positive that there aren't some hidden restrictions here. So I'm going to rewrite the whole function with factors in the denominator. Well, I don't know it's a function yet, so let's say we want to rewrite the whole equation with factors in the denominator. So if I factor x squared minus 3x minus 10, I get x minus 5 times x plus 2. And that's a relief because that means I'm not dealing with any new factors. I could deal with them if I had to, but it's nice to know I don't have to. And so now my restrictions on the domain are that x cannot be 5 and x cannot be negative 2. So in the end, if I end up with one of those solutions after doing the algebra, it may be algebraically correct, but in this expression or in this function, it would not be a correct choice. So let's go ahead and do our work. Well, this is just like factoring or like solving simple rational numbers with integers and whole numbers, except we're dealing with polynomials, and we're going to use the same steps. So first, I notice that the lowest common denominator, you don't have to write this step out, but I will just for this first time. The lowest common denominator is x plus 2. That's the smallest denominator that I can achieve in this function. So you might think x plus 2 is a smaller denominator, but it has to be common in some way. And since I have an x minus 5 factor on the right hand side, I'm stuck. I have to include that. So if I rewrite this function, creating the lowest common denominator means that I'm going to multiply the first fraction by an expression of 1 in the form of x plus 2. So all I've done is multiply the first fraction by 1. Plus, now the second fraction, again, multiplying by an expression of 1 so that I can achieve the lowest common denominator. And on the right-hand side, I already have the lowest common denominator. Now, if I were to multiply both sides by the actual lowest common denominator, I would be able to cancel all of my denominators. So if I were to multiply this side of the equation by x minus 5 times x plus 2, totally legal as long as I multiply the other side, right? And so let's be careful with our brackets since I'm describing every step in this first example. So I would be able to cancel the denominator on this side, also cancel the denominator on this side. What that means in the future is that whenever we end up with the lowest common denominator on both sides of an equal sign across the entire problem, every part of the problem contains the same denominator, we can just delete the denominators and be done with it. So now all I'm looking at is a polynomial expression, or a polynomial, equation, or a polynomial function. So I want to solve for my x, which means I'm going to distribute. Plus, distribute the second numerator. And this we know exactly what to do with. Bring all of our x's together. X squared, so 3 plus 2 is 5, take away 7. And now we just need to find what makes this expression or this equation equal 0. And so, factor, well, 5 is 3 times 2. I need a negative 2, so that'd be a negative 5. So I get x equals 5 as a solution, and x equals negative 3. Double checking that I'm not allowed to have 5 for a solution, so I'm going to eliminate that solution. And I know that for this, therefore, x equals negative 3 is the solution. Alright, so let's do an ugly one, because we all know ugly numbers have so much more character than pretty numbers. Let's solve 2x minus 5 over x plus 4x minus 1 over x plus 2 equals x plus 8 over x squared plus 2x. Alright, so now I'm looking at it, it's not as ugly as I thought, but that's okay. Let's go ahead and do it anyway. So first thing I want to do, first step always, is to factor all of the numerators and all the denominators. Now the reason you want to factor numerators is because if you can do a cancellation in the middle, you always want to cancel first before you start doing big operations with the various values. So I'm going to factor, well, 2x minus 5 over x is already factored, plus, again, 4x minus 1 over x plus 2, already factored, and that equals x plus 8, already factored, but the denominator needs to be factored. So I get x times x plus 2. I don't know what made me think that was an ugly one, but at first glance I thought it was. But now I can see by breaking it down that it's really not all that ugly. So, lowest common denominator happens to be x times x plus 2. Which means I need to create that denominator across the entire equation. So I'm going to multiply the first fraction times an expression involving x plus 2. That's the missing factor for the first fraction, but I need it to be an expression of 1. So x plus 2 over x plus 2 is the same thing as 1. Plus the second fraction times an expression of 1 involving the missing factor for this denominator, which is just x, equals x plus 8 over, well, this has the entire common denominator, x times x plus 2. Now I could do lots of combinings and such, but we already know that if I have the same denominator, and I certainly do, this denominator is x times x plus 2, this denominator is x times x plus 2, right? And this denominator is x times x plus 2. Once I have a common denominator across an equal sign, I can just cancel the denominators out. It's not magic, it's algebra, but that's a shortcut when you understand what you're doing. So I'm going to do a distribution now. 2x times x, 2x squared, 4x minus 5x minus x, and negative 10, plus x times 4x, 4x squared, minus x, equals x plus 8. So I want to combine like terms, bring everything to the left-hand side so I can find the zeros or the solutions for this equation. So 2x squared plus 4x squared is 6x squared, minus x, negative 2x, take away another x, negative 3x, negative 10, that looks to be my only constant, negative 10 take away 8 is negative 18 equals 0. Well, simple factoring here, I can divide everything by 3, and I'm left with 2x squared minus x minus 6 equals 0. And I can guess and check, but this is a great opportunity to reinforce the method, the magic method, that is the easiest way to solve these. So I have negative 6 times 2 is negative 12. Two numbers that multiply to give you negative 12, but add to give you a negative x are negative 4 and positive 3. Undo the magic, divide by 2. And so my solutions are positive, change the signs, 4 divided by 2 is 2, and 3 divided by 2 3 doesn't divide by 2, leaving an integer, so we'll keep the fraction, but change the sign to negative 3 halves. Now, I have to come back up to the original, and I probably should have done this in the first place, but it doesn't matter. You can always go back. Go back up to the original and look for restrictions on the domain. We know that x cannot be 0 because of this fraction. We know that x cannot be negative 2 because of this fraction. We know that x cannot be, well, that just gives me the same restrictions. And in the end, I have a positive 2 and a negative 3 halves, so I'm totally good to go here. These are my solutions. Therefore, the solution set, and this notation, remember, just means set notation. It's like a little box you can put all the good choices in, are 2 and negative 3 halves.